pushing curb to make pollution and reduce reliance on import of fossil fuel. And with the connection with this, you can just see Zomato and Flipkart has make one of the greatest statement at this particular point of time, that they have just come up with a news stating that it was on 6th Jan 2021, stating that Zomato would try to commit nearly 100% of its e-vehicles, particularly used for the transportation, into electric vehicle by 2030. And in reliance with this, Flipkart has also pledged and come up with the same statement that they will just make use of only electric vehicle for the e-transportation, and it is expected to be by the end of 2030. And most of the e-market has also come along with these two leading e-marketers to make the same pledge that most of the transportation vehicle, particularly used for door-to-door delivery, would be converted into electric vehicle. So in common, you can just see one particular term that has been repeated in GAR. So that is nothing but the electric vehicle. And when talking about electric vehicle, you should also have an idea about the importance of the charging station. And in reliance with this, Tata has powered over 400 EV charging station, and they have just predicted to make still 700 more charging stations by the end of December. These are the recent news in year related with the EV. And talking about the road to EV adoption, a review of government targets and policies. So government has created policies according to their regional impact all around the states in India. So state policies have outlined a good mix of demand incentives for promoting EV adoption in their particular regions. So whatever the policy that has been adopted in Delhi is not similar with Tamil Nadu or Telangana or Andhra Pradesh. So for an assumption, if you just consider the EV policy in Delhi, they have just assured that they will just install the charging station for every 3 kilometers in the highways. Whereas talking about Tamil Nadu, they have just assured that they will just introduce the charging station for every 25 kilometers in the highways. So based upon the regional impact, they have just make certain changes in the EV policies according to the states. And moreover, the road tax exemption complement for the fame to purchase has also been introduced. And exploring more about the EV policy in Delhi, so electric two-wheelers, e-rickshaw and goods carriers receive purchase incentive of around 30K, while electric cars would receive incentives ranging from 10K to 150K. So depending upon the vehicle, the incentives from the government is allowed to get varied, and merely 30% of the same has been enhanced at this particular point of time. Sorry. So at this particular point of time. So that is what is the current scenario. And government also plan to make public charging facilities. So this too falls under this EV adoption scheme according to the states. As I said earlier, Delhi is planning to install charging station for every 3 kilometers, whereas Tamil Nadu and mere states is having a different policies. So government also plan to make public charging facilities accessible for every 3 kilometers in Delhi. And talking about electric population at this particular point of time, in late 2014, the electric vehicle population was not enormously high. So the overall electric vehicle population was very minimal. But as the year keeps on increasing, the penetration of EV has moved to a greater extent. And with accordance with the previous news, whatever we have discussed earlier, it is predicted that merely the electric vehicle population would take the maximum peak by the year of 2030. So it is well agreed with the whatever the news that we have seen, that Zomato and Amazon, Flipkart, most of the uh, manufacturers are targeting to convert all their transportation vehicles into electric vehicles, particularly by the year of 2030. And they are also suggesting to make use of cycles to get converted into a green environment. So I hope you might have also read that particular news at the recent newspaper. And talking about the electric population, in the year of 2010, most of the vehicles in India was dominated by only purely internal combustion engine. So it was only internal combustion engine ruling the time scale of 2010. But as the year keep on increasing, the role of internal combustion engine have slowly started to get lose its market space in the overall overall two-wheelers and four-wheeler sectors. So particularly by the year end of 2020 or later, the slope would face a drastic change after this particular time scale. So after this only the internal combustion engine will be live by the term of HV or PHEV. So HV stands for hybrid vehicle, whereas PHV stands for plug-in hybrid vehicle. So by the year of 2021 or later, you can just see only the internal combustion engine will be alive by the term of HV or PHV. So we will discuss more about these two terms in the upcoming slides. And agreeing well with this particular profile pattern, so new Yamaha Fesino 125 Hybrid was launched with more features and lower cost. So this was the news in air by July 22, 2021, which is not too far from today's date. So this is earlier was a purely internal combustion engine based two-wheeler. So they'll be mainly making use of petrol for its propulsion, but they have come up with a new term along with this. So they have tried to add a term hybrid to this particular vehicle, and they have claiming that they have come up with an hybrid vehicle variant of the existing model. So agreeing with this particular statement, the internal combustion engine will be alive only by the name of hybrid vehicle or plug-in hybrid vehicle from the upcoming years. So smart motor generator system on new Yamaha Fasino 125 hybrid function as an electric motor to give power assist when the rider accelerates from a standstill condition. So it will give you a small assistance at certain time scale. So we'll try to understand more about the degree of hybridization and other stuff as moving further. So this talks about the electric vehicle population at this particular point of time, and it is also agreeing well with this particular quarter year of electric vehicle sale all over the world. So the internal combustion electric vehicle market share has faced a huge drop by the year of 2021, whereas the electric vehicle market share has slowly increased its penetration to a certain extent by the half quarter of 2021. Agreeing well with it, Volkswagen, Tesla is having the maximum percentage, whereas the other companies are also having a minimal share in this. So this what is the current scenario of electric vehicle population at this particular point of time. So to start with this electric vehicle, let us just try to understand the history of electric cars at this particular point of time. So nothing new under the horizon. Both electric cars and internal combustion engine has been around for more than 100 years. So both started their career to the automotive market at the same time scale, both internal combustion engine and electric vehicle. But some of the electric vehicle was suppressed by internal combustion engine for past 100 years. And once again, the EV has started to emerge itself and gain certain percentage in the market share. So it was in 1832, the first electric vehicle was developed. So kindly check with the time scale. It was in 1832. And in meantime, it was in 1893, the internal combustion engine based on gas power was get commercialized. So 1832 and 1893 doesn't have a very huge gap, and it says that both are under the same horizon. And even at this particular time scale of the late 18th century, electric cars gained popularity. So as both have started their career at the same time scale, at the time of 1899, the electric gained popularity, especially on the society woman. So that is working woman highly preferred electric cars rather than picking an internal combustion engine. If you just think about the internal combustion engine at that particular time scale, you need to have a crank in the front, and whatever the emission that emits from the rear side would be enormously high. So the society women or working women highly preferred the electric cars rather than picking an internal combustion engine at that particular point of time. And later on in 1901, the edition takes on electric vehicle with batteries. So now people are discussing about Tata Nexon with an electric vehicle or pure EV, but the electric vehicle with batteries was introduced in the time scale of earlier 19th century. It was in 1901, but as of now we are in 2021. So think about the time scale. For nearly 120 years, only people were discussing about the internal combustion engine. And it was in 1901 the first hybrid electric cars were introduced. So, as discussed in the previous slide, Fasino has come up with the statement that they are just coming up with an hybrid vehicle variant by 2021. But the hybrid vehicle was introduced to the human mankind at the time scale of 1901. So, for past 100 years, only the internal combustion engine was ruling the entire automotive market field. And it was in 1920 to 1935 the electric vehicle has slowly start to fail to take a place in the automotive market share. So the one main reason that people actually address at that particular point of time is the charging station facility and the overall weight of the system. So the overall weight of the system at that particular point of time, talking about the battery, was enormously high, and the time for charging and the amount of power that can be drained from the battery was not sufficient to make and long travel from, particularly focusing on the transportation. So this makes this slowly disappear the role of electric vehicle in the automotive share entirely. So this happened actually in the time scale of 1920 to 35. But once again, the electric vehicles start to make a small role in the automotive share, particularly in the time scale of 1968 to 1970. So this happened because of the gas price start to roar to a drastic extent. So the dependency of gas price or the dependency of fuel was focusing on one particular nation rather than it is having multiple points to have a supply point. So this make the gas as one major threat to the entire automotive field, particularly the internal combustion engine. And the dependency of gas focusing on one particular nation make an issue with the ruling nation at that particular point of time. So all put together, as the gas price keep on increasing and the dependency on one particular nation focused or paved a pathway for the researchers all over the world to think an alternate source of energy rather than relying on the gas as a main energy source. So this was well assured with the 1971 as the electric vehicle was once again there in the newspaper and air as the NASA lunar rover was propelled with electricity based uh, vehicle at that particular point of time. So this news was there in air, and this make a small spark among all the automotive manufacturers to think uh, of making use of electricity as an alternate energy source rather relying on the existing petrol and gas as an energy source. And it was also well assured by the year of 1973, the next generation electric vehicle as a prototype was introduced to the human mankind. So the General Motors developed a prototype for an urban electric car, and it was just displayed in the symposium where most of the automotive manufacturers were gathered, and it was displayed in the symposium of low pollution power system at the time scale of 1973. So once again, the electric vehicle have started to emerge itself in the mid of 1970s, and all put together, the first hybrid vehicle was introduced to the human mankind by the year of 1997. So it was in 1901 where the invention of hybrid vehicle was introduced, and it was in 2000 actually. So it was in 2K where the Toyota Prius have come up with the first mass production of hybrid vehicle. And for past these 100 years only, people were relying on purely internal combustion engine propelled with either petrol or diesel as an energy source. And here comes the hero of our current electric vehicle. So it was in 2006, the Silicon Valley based startup, the automotive market, and it just make the automotive manufacturers to have their own electric vehicle once this statement was there in gap. So Tesla was initially a Silicon Valley based startup. They just announced that they will just produce a luxury electric sports car with a range of 200 plus miles. So it was too far at that particular point of time, and this make a threat to most of the automotive manufacturers, and all the automotive manufacturers have tried to or accelerated to work on their own electric vehicles. So this particular statement or this particular year where the role of electric vehicle have slowly start to have its penetration in the overall automotive makers share percentage in the worldwide. And this what talks about the history of electric vehicle. And talking about the definition of electric vehicle, an electric vehicle propelled by an electric drivetrain draining power from a rechargeable battery or from a portable battery. Either it can be refillable or electrical energy source from fuel cells, solar panels, etc., which is manufactured for the use of public roads. And talking about the main advantage of the electric vehicle, it doesn't emit any tailpipe emission. So EV have no tailpipe emission, reducing CO2, SOx, NOx, and PM to a greater percentage. But one thing you need to be very much clear at this, uh, with respect to this statement, as we have said earlier, the penetration of EV have slowly start to get increase at this particular point of time, and this would result in a higher demand in electricity. This would result in higher demand in electricity, and sooner or later you might get this particular news stating that government would announce you much more incentives for installing solar station in the rooftop of all your house. So because to handle this particular electricity demand, government should rely on an alternate energy source to create electricity, because whatever the electricity as of now produced is handled by the power plants, either it can be thermal or any other power plant. So once the electric vehicle penetration is allowed to get increased, this would put an enormous pressure on the demand for electricity. So all put together, it would have a great impact in the power plant to produce excess electricity. And for producing excess electricity, once again, you should rely on fossil fuel. So talking about no tailpipe emission, it should be addressed with one particular term along with this, that no tailpipe emission from the user end. So once the electric vehicle penetration has increased, whatever the emission that emit from your particular vehicle would be restricted. But to handle this particular electricity demand, the thermal power plant should run for an excess time and handle the overall demand. So all put together, the fossil fuel supply to the thermal power plant would get increased. So the thermal power plant would emit excess emission, whereas the internal combustion engine used by yourself won't emit emission. So it doesn't mean when you are just getting switch over to an electric vehicle, it would completely cut away the emission to a greater percentage. Emission from the user end would be cut down to the maximum percentage, but the emission from the thermal power plant would get enhanced to a higher level to handle this particular issue. So that is why we are just expecting that we will sooner or later expect a news stating that we will have certain incentives to install a solar station or solar panel based rooftop setup to create our own electricity to handle the future demand, particularly in the upcoming years, because we are just relying on the year of 2020 2021, and we are just expecting a huge penetration of EV vehicles by 2030. So to handle that particular demand in near future, we should rely on an alternate source of energy to produce electricity. So that is what going to be the major threat in the upcoming years. Talking about the battery power electric vehicle and hybrid electric vehicle. So the battery power electric vehicle, on the other hand, possesses some advantage over the conventional ICE, such as high energy density and zero environmental pollution, particularly from the user end. So particularly from the user end, that is from yourself and not from the overall objective. However, the performance, especially the operation range per battery charge, is far less compared to the IC engine vehicles. So that is one great disadvantage why the penetration is not too high even at this particular point of time. So extensive research are running on this particular statement than IC engines due to much lower density of the battery than that of the gasoline. So talking about hybrid vehicles, because huge amount of investment has been carried over for internal combustion engine based industries and its reliance industry and its related industries. So you can't completely eradicate the internal combustion engine and move over to an EV at this particular point of time, because there would be a great loss for this particular sector. So to make this internal combustion engine alive, what they have tried to come up with is a hybrid engine. come up with is they have tried to add a term along with this existing internal combustion electric vehicle talks about making use of two power sources. So you will have the existing internal combustion engine. Along with that, you will have the combination of electric motor and battery. So this would be the primary power source. So this would be the primary, and this would be the secondary. So primary, secondary says that the maximum percentage would be handled by the internal combustion engine. So 51% of the energy share would be handled by the internal combustion engine, and 49 would be handled by the electric motor and battery combination. So stating this that a primary power source and the secondary power source would be combined together, having the advantage of both internal combustion engine and EV to handle their own disadvantage. So this is what is the current scenario. So you can't completely throw away an internal combustion engine and make it alive for next 10 to 20 years. So this is what is the current scenario. So you can't completely throw away an internal combustion engine and make it alive for next 10 to 20 years. So this is what is the current scenario. When talking about the types of EV, so the EV are mainly classified into these 5 types in a broad manner. So first one is hybrid electric vehicle. So this hybrid electric vehicle is further branched out as series parallel combination. So which will be making use of two power sources. So the primary source would be electric motor, and fossil fuel battery combination. So the overall power would be delivered from both the cases, that is from both motor plus battery and fuel tank plus internal combustion engine. And talking about plug-in hybrid vehicle, so you'll have an additional option to charge it from the plug-in point. So by means of a plug-in point, you can just charge your battery. But in this case, the power would be generated from the era of internal combustion engine comes to an end. So after that, only the primary source would be pure the battery plus motor combination. So whether you're just going to rely on the plug-in option or you are going to rely on an hydrogen as an energy source or solar as an energy source. So these three follows the extension of battery powered electric vehicle. So whether you're going to rely on battery or fuel cell or any other energy source to create electricity. So these are the future vehicles which is going to be rule the world after 2050 or later. But till 2050, you can just assure that the internal combustion engine will be alive, but only by the name of hybrid vehicle. And even at by the name of hybrid vehicle, the primary source would be only internal combustion engine. So we'll understand this much more better in the upcoming slides anyhow. So talking about hybrid vehicle, one particular term that strikes at most of the time is the degree of hybridization. So the term degree of hybridization is classified into three main terms. One is micro hybrid, mild hybrid, and full hybrid. So what is this micro, mild, and full hybrid? Is if you are having a demand of around 100 kilowatt of power, if the 100 kilowatt of power is only delivered by your internal combustion engine, that says that the degree of hybridization is 0. And if you are having a demand percentage of power is delivered by your internal combustion engine and 25% of power is delivered from your electric motor, the degree of hybridization is 25. It says that what is the percentage of the electric motor delivering power to the overall demand talks about the degree of hybridization. So this particular case, if the overall power is delivered only by your electric motor and battery combination, it says that your degree of 100%. If it is only delivered by your internal combustion engine, is your degree of hybridization is 0%. So you might have seen various vehicles as of now. So Maruti Ciaz is of mild hybrid, and whatever the two-wheelers and four-wheelers are of micro hybrid, and you might have seen variants coming with full hybrid. So most of the vehicles, particularly four-wheeler vehicles, are coining themselves as hybrid vehicle based on this particular strategy state with respect to the degree of hybridization. So we'll just explore more about this in the upcoming slide. So what is this degree of hybridization? So first let us just start with the micro hybrid. So you can just see the overall power would be handled by the internal combustion engine and motor. So in this particular case, the role of motor would be only utilized for the start and stop operation. So you can see most of the two-wheelers as of now doesn't have a kickstart option. So it doesn't most, I think completely the kickstart option in the vehicle has been completely eradicated. So only you will have and start a power start option. So this power start option is known as the micro hybrid. It says that in the existing internal combustion engine, you will have an motor plus battery combination, and this motor would be utilized for just starting and stopping your vehicle. So it says that all the two-wheeler as of now in the market are falling under the category of micro hybrid. So it is just only an add-on that is allowed to get fit to your existing internal combustion engine. So they will just remove the kickstart option and they will just make use of a motor to start your vehicle. So this particular case talks about the micro hybrid. So this micro hybrid is having one additional option that you will have the existing internal combustion engine motor, and this motor combination would be used for start and stop operation. Apart from that, you can just effectively use it for the regenerative braking. So I hope you are aware about the regenerative braking. It says that effectively using the waste heat energy to convert the same into the electricity. So at the time of braking, so the unwanted kinetic error, and that would produce electricity, and that can be effectively used to charge your battery. So talking about micro hybrid, it would be a combination of internal combustion engine and a motor. And when talking about micro hybrid, there won't be any major change in your vehicle. So only they will just have an add-on device that is fit with your existing internal combustion engine, and that motor would be effectively used for only two major operations. One is start and stop. So that is nothing but our power start option. So whatever the vehicle, two-wheeler, either it can be an scooty pep variant or a gear-based variant, most of the vehicle is having the start and stop operation. And apart from this start and stop, it can be used for the regenerative braking. So talking about mild hybrid, so apart from this would assist you in the same case start and stop and regenerative braking. Along with that, it would be used for the power assist. So this is what the Fesino have come up with the statement. I hope you can just see it over here. So this particular Fesino vehicle has come up with an hybrid variant that this electric motor will give you a power assistance when the rider accelerates from the standstill condition. Assume you're at a standstill condition or particularly in a signal, and you are going to accelerate your vehicle. So at the time of acceleration, you will try to give excess amount of fuel to propel the end wheels. So at this particular point of time, this electric motor will assist you to propel the vehicle in a better way. So this is what talks about the mild hybrid variant. So this is what talks about the, so and in this particular point of time, you should be very much see a term known as engine downsize. So you should be very much clear about why the engine need to be downsized. So talking about you are having an existing vehicle which is around a mass of 400 kg, and you have been asked to convert it into a hybrid vehicle. You are going to add a motor plus battery along to this existing system. So let us assume all put together, your overall weight of the system would get increased into 600 kg. For an assumption, motor plus battery is weighing around 200 kg. So the overall weight of the system is get converted into 600 kg. So overall weight of the system get increased, then the fuel consumption would get increased. So our main objective is we need to get a better advantage when you are getting switch over to the hybrid vehicle mode. So as you are getting hybrid vehicle, getting convert your vehicle into hybrid vehicle mode, what you have to do is you have to downsize the engine and reduce the overall weight of the system. Unless and until you reduce the weight of the system, you won't get or you won't enjoy the advantage of converting your vehicle into an hybrid vehicle variant. So that is the reason why you can just see the overall size of the internal combustion engine has been reduced. So we'll try to understand how the engine is allowed to get downsized in the later slides. But the term downsize has been added with this existing case because of this particular weight issue. So once the weight is allowed to get increased, the fuel consumption would get increased, and you won't enjoy the advantage of hybrid vehicle mode. And talking about full hybrid, so even at the particular point of full hybrid, the role of motor plus the related components would not exceed 49% of its power deliverable. The maximum percentage would be handled by the internal combustion engine, because the internal combustion engine would be the primary source and the motor would be the secondary source. Apart from this start and stop, regenerative braking, and power assist, you will have a short electric drive extra, or you can have an extended electric drive which you can just charge it by means of an additional plug point. That what talks about the plug-in hybrid. And even you can just see, as you are getting higher with your battery and motor combination, you should focus more on engine downsizing. And with this, the era of internal combustion engine would come to an end, and you can just see the internal combustion engine has been completely eradicated, and this is what talks about the pure electric vehicle. So as further in this advancement, rather focusing on battery, people have started to explore different options of ultra capacitor or fuel cell based vehicle or solar based energy to produce electricity. So this is the current conversion of your existing internal combustion engine into hybrid mode, from hybrid mode to electric vehicle. So this is there, this would be alive for next 20 to 30 years, because there is a huge amount of investment and dependency on pure internal combustion engine. But it won't be able to sustain after 2050, and after 2050 people would get completely switch over to electric vehicle. But at that particular point of time, we need to think about how the electricity would be produced to handle a huge demand which we are going to face in near future. I hope you are able to clearly understand the difference between electric and hybrid vehicle and its classification. And talking about hybrid vehicle technology, so this has been addressed in the previous slide, where in terms of micro HEV, the percentage of degree of hybridization would be from 5 to 20%. So merely 5 to 20% of power would be our the demand, whatever raise for that, the power would be delivered from 5 to 20% from your battery plus motor combination, and it would be effectively used for only start and stop operation. And talking about mild hybrid, it would be 20 to 30% of DOH. So DOH talks about degree of hybridization, and for plug-in hybrid, it would be from 30 to 50%. It won't be 50; it would be closer to 49% and mere. Would be get converted into electric vehicle, and the secondary would be converted into your internal combustion engine. And the last one is plug-in hybrid vehicle. So rather relying on the power source from internally, you can have an external power source to produce electricity and allowed to get purpose. So these are the broad classification of an electric hybrid vehicle technology. And talking about engine downsizing, so downsizing an engine has nothing to do with the performance. So the existing performance is allowed to get relay. So let us assume it produces an power of around 60 kilowatt. So whatever the downsize would more or less produce the same power output, but the overall weight would be effectively reduced. So simply it is the method to reduce the weight to the minimal possible weight to power ratio, and this one talks about the minimal possible way to achieve the best breed of power to weight ratio. So let us assume it is having a weight of around 100 kg, and this would have a weight of around 75 kg. So the overall weight has been reduced drastically, whereas the power is not compensated to a greater extent. So this what talks about the engine downsizing. And most of the cases, it is now allowed to get coupled with a turbocharger or a supercharger. So the upcoming vehicles is allowed to come able to come up with the turbo or superchargers. Mainly, this will assist you to a greater percentage to reduce the weight and enhance the power output. This is a profile of an wastegate type of turbocharger, and people are also working on VGT to deal with this particular power to weight ratio. And the conceptual illustration of hybrid electric drivetrain talks about. So this is the power flow of the hybrid vehicle drivetrain. So the energy source would be the fuel tank, and the energy converter would be your internal combustion engine. Whereas the powertrain 2 talks about the energy source would be your battery, and the energy converter would be your electric motor. So this talks about the hybrid where you will be making use of both internal combustion engine and battery plus electric motor combination. So this would be able to run your vehicle in 9 different modes. So this would be allowing your vehicle, hybrid vehicle, to run in 9 different modes. First, in engine alone propulsion mode. So in case of engine alone propulsion mode, whatever the demand that is raised in the end wheels would be handled by the fuel tank and internal combustion engine, and that would be, so that would be delivered to your end wheels for your vehicle propulsion. Whereas talking about pure electric hybrid vehicle, so the battery plus electric motor combination would be coupled together, and only the power would be drained from this battery and electric motor, and that would be effectively used to drive your end wheels. So whatever the demand that is raised in the end wheels would be handled by only the battery plus electric motor combination. And talking about the hybrid traction mode, we will try to combine both the sources. So as described in the previous case of Fesino, so starting from standstill condition to make an short acceleration, along with your internal combustion engine, certain amount of power would be delivered from your electric motor to assist the demand what is raised in the end wheels. So this talks about the hybrid traction mode. And fourth one is the regenerative mode. So regenerative mode talks about the power would be delivered from the end wheels to the energy converter. So you can just see the arrowhead in the reverse direction over here. So once you are just allowing to make a break or retrieving the waste kinetic energy effective in an effective way, so that rotational energy can be effectively used to produce electricity, thereby converting your motor into generator, and that electricity can be stored in your battery for future use. So this talks about the regenerative braking, and further or different combination of options. So it charges the battery while the vehicle is at standstill condition, coasting or descending or a slight grade. So the engine would charge your battery. So when standing in an idle condition, so in most of the vehicles, you have just come up with an option of an idle off condition. So once standing in an signal, your vehicle would be completely allowed to get switch off. And just even if you just press your accelerator pedal or change your gear, your vehicle will be allowed to get start. So at this particular point of when your engine is allowed to start, this engine power would be effectively used to charge your battery. And next one is both regenerative braking and internal combustion engine will charge your battery. So based upon the state of charge of your battery, if the charge is required for an higher percentage, so both your internal combustion engine and the regenerative braking would be combinedly used to charge your battery. And next one is engine propel the vehicle and charge the battery simultaneously. We will be exploring more about this using a Sankey plot anyhow in the upcoming slides. And the next one is engine charge the battery and the battery supplies the power to the load. And next one is power flow into the battery from the heat engine through the vehicle mass. So these are the 9 different modes by which your hybrid vehicle would be running at any point of time. So based upon the situation, these different modes would be get switched on. So this pictorial representation talks about the architecture of mild hybrid drivetrain. So this is your existing internal combustion engine. You'll have an internal combustion engine, clutch, and a gearbox, and your end wheels. You won't disturb the overall existing flow of the system. Just you will be adding a pulley and an electric motor, inverter, and battery. So in this particular case, you have not disturbed the existing system. Just you have tried to add this particular combination to your existing system in the rear side. So without making any major changes, if you are going to convert your existing internal combustion engine into a hybrid vehicle, so that particular scenario is known as the mild hybrid combination. So there are different points at which you are going to couple this with an belt drive. So either it can be before on the rear side of your engine by making use of a pulley drive, or in between the internal combustion engine and the gearbox. So there are different combination based upon the scenario. They used to get different combinations. So I hope you are clear about the mild hybrid drivetrain in a brief manner. And talking about the different modes of operation. So either it can be internal combustion engine mode or battery mode. So if the internal combustion engine and the battery is combinedly acting at particular point of time, it would be running on this particular mode. And if you are just relying only on battery alone mode, this would be over here, and it is pure internal combustion engine and engine braking mode and regenerative braking mode, and the combination of internal combustion engine and charging mode. So in this overall scenario, the green color talks about the traction mode. So that says that the vehicle would be in motion condition. And the sandal color or the brown color talks about the braking mode. So at the time of braking, the internal combustion engine power might be higher. So at this point of time, it would be less than zero. And at the time of regenerative braking, the same might happen. So the battery power might be less than zero, or the internal combustion engine power might be less than zero, because only when these two powers are cut off, the regenerative braking would be active. So these are the different modes of operation at which the power would be flow. So talking about the Shanke plot for an mild hybrid drivetrain, where you can just see the battery, inverter, and electric motor combination, which is allowed to the existing internal combustion engine by means of an belt drive. So along with that, the clutch and gearbox is kept. So this is the existing internal combustion engine. Only they have just kept it as an add-on device. So if you just try to plot the overall power flow for this particular case, if the overall power flow, so the overall power produced from the internal combustion engine as in brake power, okay, indicated power over here. So merely certain amount of power would be lost as in friction, and the remaining power would be delivered to the transmission. So even at the time of transmission, you will have certain transmission losses, and this would be the remaining power that to be delivered to your end wheels to handle the demand which is raised at the end wheels. And when you are just able to combine the battery plus electric motor combination to this existing system, so this is the overall power that would be delivered from your battery plus electric motor combination. So it would be get added with this existing power that is coupled with the internal combustion engine. So even at this particular point of time, you will have certain driving losses as you are just connecting with a belt drive, and this would be assisted to the end wheels by these means. So this is how the overall power flow for an Shanke plot would be looking like. And talking about the Shanke plot for different modes, so this talks about the internal combustion engine plus battery mode. So this is the power from internal combustion engine, and this is the power from internal battery, and all to put together, you will have the overall power. Let us assume of length A, and only if you are propelling on internal combustion engine alone, you will have a power of around B. And if you are just taking certain amount of power to charge your battery, so this is the overall power that is allowed to get produced, and this is the power lost due to friction, and they have taken certain amount of power to charge your battery, and they have taken remaining power to propel your end wheel. So this is C. If you just try to see the overall energy, so A would be higher, B would be lesser, and C would much more lesser. So this is how the power, the end wheel power would get vary when you are running your vehicle at a different mode. And this talks about the combination of internal combustion engine and battery or pure ICE. And talking about battery only mode and completely get rid of your internal combustion, as it is a combination of mild hybrid, you will have only 0 to 20% of power that would be delivered from your electric motor combination. So if you just make use of this battery alone mode to handle the end wheel, so whatever the power that is delivered by your electric motor would be very minimal. And at the time of braking, you can just see the power would be lost to your internal combustion engine, and there would be very minimal power to the battery, because it is just connected by means of a belt drive. And at the time of regenerative braking, you can just see excess amount of energy is transferred to charge your battery. So this is the Shanke power flow plot for your internal combustion engine and battery in a brief manner. So talking about hybrid vehicle drivetrain, so whatever we have discussed talks about the mild hybrid, and moving further in the hybrid vehicle drivetrain, it is further branched out into series hybrid and parallel hybrid. So in case of series hybrid, as like the existing case, you will have a fuel tank and an internal combustion engine. combustion engine. And talking about the electric vehicle part, a battery and an electric motor, and this would be coupled with a transmission system to handle the end wheel demand. So here you can just see you are having both internal combustion engine and EV, but this series is nothing but making use of electrical energy to propel your vehicle. So the power would be in this particular fashion that from the fuel tank, the power would be delivered to your internal combustion engine. So from the internal combustion engine, the rotational energy is given to your generator, and that generator will produce electricity, and that would be passed through a power converter from the battery, from there to electric motor drive and a motor. And that would be supplied to your transmission system. And similarly, talking about the parallel hybrid drivetrain, so you will have the same combination of internal combustion engine and a gasoline tank. Here you can just see the fuel tank and the internal combustion engine, and here you can also visually see you are having a battery plus electric motor combination. So in this particular case, whatever actually happens is you will be connecting these two, ICE and EV, in a parallel manner. So this would be most often case a mechanical coupling. So the power would be delivered simultaneously from internal combustion engine and battery in a parallel manner. So in this particular case, it can be coupled in either before the engine or before the clutch, before the gearbox, or at the end wheels, or after the gearbox. So there are different combinations which you can try to place this in your existing engine combination. And talking about the hybrid vehicle drivetrain, so the architecture of hybrid vehicle is loosely defined on the connection between the components that define the energy flow routes and the control parts. So the traditionally talking about the hybrid drivetrain classification, it is based on the series and parallel, and it is even further branched out after series and parallel into series parallel combination and complex hybrid combination. So in case of HEV, there are two kinds of energy flow. So either it can be mechanical energy or electrical energy. So this is what talks about the electrical coupling and mechanical coupling. Talking about the series hybrid drivetrain plot, so you can just see you'll have a fuel tank and engine. From there, you'll have a generator, and here it would be coined as the electrical coupling. So from here, the electrical energy would be effectively used to flow through a motor and traction motor to handle the end wheel demands. And talking about the different Shanke plot for your series hybrid drivetrain, you will have a fuel tank, internal combustion engine. From there, the rotation energy is given to a generator with power electronics, and from there, the electrical energy is allowed to flow through the traction motor, and this traction motor will handle the end wheel demands. And meanwhile, you will also have a battery to do the same or handle the power to the traction motor. So it would be a simple mechanics, and it will have an optimal IC engine speed and easy to control. Whereas you will have the same combination as described earlier. You can just run either engine alone mode or battery only mode, or the combination of engine plus battery mode, or you can do the same of engine can certain power to charge your battery and certain power to run your traction motor, or you can just deal with the regenerative braking mode. So this could be very much understandable with this particular Shanke plot. So where you can just see the fuel tank and internal combustion engine. From there, the rotational energy is given to your generator with power electronics, and this power could be delivered to your traction motor and thus would handle the end wheel demands. So in this particular case, it is able to run only in internal combustion engine mode, where you can just see the power flow is from the internal combustion engine to the traction motor, and it is an electrical coupling part. And either it can be pure electric vehicle mode, where the battery would deliver the power to your traction motor to deliver your end wheel demand, or it would be the combination of both, that is the hybrid drivetrain mode, where the power would be delivered from your internal combustion engine and from your battery to handle the end wheel demand. And this is the IC engine plus battery charging case, where certain amount of power would be delivered from your internal combustion engine to handle the end wheel demand. Among that, a minimal amount of power would be effectively used to charge your battery, which doesn't have a plug-in option. So we are as of now talking about, we are not as of now talking about the plug-in hybrid drivetrain. And in case of regenerative braking, from the end wheels, the power would be effectively used to charge your battery. So these are the different modes at which your series hybrid drivetrain power flow would happen. And talking about the parallel hybrid drivetrain, where we will be trying to couple both the power from internal combustion engine and battery using a mechanical coupling. So you'll have an internal combustion engine, clutch and gearbox. So the power would be get combined with your battery, inverter and electric motor by making use of a mechanical coupler, and that would supply to your end wheels to handle the end wheel demand. So this particular battery and electric motor can be placed at different combination according to position according to the particular requirement. Either it can be placed at before the engine or after the engine, that is before the clutch, and in between the clutch and the gearbox, and it can be at the end wheels or after the gearbox. So the word parallel refers to the fact that the torque of electric machine is added to the torque of internal combustion engine, and the total torque propels the end wheels. So here it is deal with a mechanical coupling where both the torque from internal combustion engine and end wheels are combined together to handle the end wheel demand. And this is the configuration for your parallel hybrid drivetrain, where you can see fuel tank, engine, and battery, electric control, and traction motor. And here you can have a mechanic coupler, which will be more or less often an epicyclic gear train. And from there, by means of a mechanical transmission, it will just have a deal with the n wheel demand. So this will also falls under that different modes. Either it can be pure electric traction mode, or pure engine mode, hybrid vehicle mode, engine traction with battery charging, regenerative braking, battery charging, or hybrid battery charging mode. So these are different modes at which your parallel hybrid drivetrain would be running. And talking about the mechanical coupling, in most often cases, we'll be making use of an epicyclic gear train to combine these two energy into one single unit. So focusing on the time, I will just move forward. And talking about the Shanke plot for this particular case, here I have just tried to place the power flow in between the differential and the gearbox. So talking about internal combustion engine and battery. So this is an power flow for hybrid vehicle drivetrain, which make use of parallel combination. So here talking about internal combustion engine plus battery. So this would be the overall power that would be able to deliver, noted down as A. If it is pure internal combustion engine, and certain amount of power would be used for charging. So as described earlier, the overall power would be in this particular fashion. And talking about battery, compared to the previous case, the power of the battery would be somewhat higher than the mild hybrid. So when talking about series and parallel hybrid, it would fall under the category of either full hybrid or full hybrid or mild hybrid. So whatever the power that delivered by means of micro hybrid would be very minimal, and by means of braking, the power would be retrieved back to the internal combustion engine. And discussing about the regenerative braking, maximum amount of power can be effectively used to charge your battery. So this is the Shanke plot for your parallel hybrid drivetrain. And talking about the real-time application of your series parallel combination in the automotive market. So both series and parallel are old school books. So they are not allowingly use this effectively for the vehicle production. So they are just making use of the combination of both series and parallel into one single unit. If you just see this, as described earlier, you are going to combine two energy source. One is internal combustion engine and electric vehicle part. So in case of internal combustion engine, you will have a fuel tank and an internal combustion engine. And in case of your electric vehicle part, you will have a battery and a motor. So if you just see this very clearly, you can just see you are having a gasoline tank and engine, and you are having a battery and electric motor. So what talks about the combination of series and parallel is, so in case of series, the rotational energy from your engine would be transferred to a generator, and that electrical energy would be effectively used to run the in traction motor. And talking about parallel hybrid, both the energy would be coupled into a single unit, and that would handle the n wheel demand. So when you are just combining these two techniques in a single unit, you need to focus on both the cases. So discussing on series hybrid alone. So in case of series hybrid, you can just see you are having an engine, after that a power split device, and from the power split device, the power is delivered to a generator, and from the generator, power converter, battery, and electric motor, and that is used to give the power source to the transmission system and handle the end wheel demand. So this agrees the power flow, or this agrees the architecture of series hybrid. And talking about the parallel hybrid, you will have a gasoline tank, from their internal combustion engine, and by means of power split device, you can deliver the power to the transmission system, or in this particular combination. So you will have a battery, electric motor, and by means you can deliver the power to the transmission system. So in the existing case, they have introduced one common part into the series and parallel hybrid architecture. So that is the power split device. So when you introduce a power split device to the existing case, what actually happens is it would be able to deliver the power either to the transmission or to the generator. So this power split device incorporation would convert your existing system into a series and parallel hybrid configuration. And even complex orbit configuration will have much more complex architecture, and I'm not focusing more about it. And this series and parallel hybrid configuration is what used in Toyota Pyrus. So as described earlier in the history, so it was one of the highly mass production hybrid vehicle at the early 20th century. And Toyota Pyrus make use of series and parallel hybrid configuration. 21st century. And talking about the plug-in hybrid drivetrain, apart from the existing scenario, you will have an additional outboard charging point to charge your vehicle. So this is a pictorial representation of a parallel hybrid drivetrain where you can have an internal combustion engine, that power would be delivered to your transmission, or battery plus electric motor, and that would be able to deliver the power to your transmission. And this plug-in hybrid drivetrain in terms of parallel is effectively used for Chevy Volt vehicle, so which make use of plug-in hybrid drivetrain with a combination of parallel hybrid drivetrain architecture. And talking about battery-powered electric vehicles, so our main scenario is we are going to replace the existing internal combustion engine and the fuel tank in your existing vehicle and replace it with an electric motor and a battery. So in the place of fuel tank, you need to fit a battery, and in the place of your internal combustion engine, you need to replace it with an electric motor. So this what talks about the conversion of your existing vehicle into an BEV. So the major disadvantage of this BEV is the weight of the system would be enormously high, because the weight of the battery is higher at this particular point of time. But in later stages, the battery weight would also be reduced to handle this particular issue, and lower flexibility. So lower flexibility by means the varied discharge range of your battery would degrade your battery performance, and that might affect the overall uh, battery usage for a long term. And the performance degradation related to this would cause the use of this type of EV to fade out in near future. So these are the major disadvantage that would be addressed when talking about BEV. And the configuration of BEV has been presented over here. So where you will have and battery pack, the overall battery pack would be placed under the footrest of your vehicle, and from there, by means of a power converter, the power would be delivered to your electric motor or generator, and it would be transferred to your transmission system to handle your end wheel demands. And you will have an additional option to have a plug-in charging. So this can be either charged by means of a grid electricity at the charging station, or house outlets. And even if you just purchase any two-wheeler electric vehicle, as of now, they are just trying to install their charging port at your household itself. So they will install their charging grid at their household itself to charge your vehicle. And as described earlier in the EV policies, government is also planning to install charging station for every 3 kilometers or 20 kilometers to handle this grid electricity charging station in and around the highways. And non-grid energy source such as solar or onboard recuperative energy would handle the demand to a certain percentage. So the BEV can potentially emit zero greenhouse gas emission only from the user end, as described earlier. So the main components present in an BEU would be an accelerated pedal and motor drive control and the traction electric motor to handle the in-wheel demands. And talking about the power flow, which we have addressed earlier, and the ideal performance characteristics that is required for a power plant has been presented over here. That is, at low speed, we are in need of an high torque. And as the speed get increased, the torque would slowly fade out. And nominally, in the initial case, the power output would be increasing in a minimal percentage. And we need a constant output for an ideal performance characteristics of a power plant. And relying on the existing internal combustion engine, here you can just see the profile of the torque versus speed profile of an ideal internal combustion engine. Either it can be a petrol or diesel vehicle. So you can see this particular plot and this particular engine specification that's stating that the maximum torque is allowed to achieve only at one particular RPM. So the maximum torque profile is allowed at one particular RPM, and the maximum power is allowed at only one particular point. So, but whatever the ideal requirement says that you need a high torque at low speed and a constant power output at a high speed, but that is not actually delivered by your internal combustion engine. So you might have seen this particular part that your engine would deliver a maximum torque at one particular RPM and maximum power at one particular RPM. So it doesn't mean that you should always run your vehicle at that particular point. So that way you will always have an economy zone in your vehicle. So this economy zone or the green color plot in your overall speedometer says that you will try to run your vehicle in the closer to maximum power region. So if you just try to run your vehicle to closer to the maximum power region, you will get a better power output and a better mileage. So that is the reason why you will always get a better mileage when you try to run your vehicle in the economy zone that is closer to the maximum power point. If you exceed this or fall below the maximum power point, you will be getting a very low power output. So it is well agreeing with whatever the power plot they have presented over here. And the another disadvantage when you are just dealing with your internal combustion engine is that it won't be able to deliver a superior torque at low ends. To handle this particular issue only, we are just making use of a gearbox. So whatever the role of gearbox is used to fill this particular gap. So this is the torque profile of your internal combustion engine. But what about the torque that we require for an ideal power plant is a high torque. So to fill this in-between gap, we are just relying on an gearbox in your existing internal combustion engine. So the role of gearbox is to fill this particular gap. So when you just try to make a plot for this particular scenario, so you can just see the profile of first gear, which would be able to deliver a high torque, and second gear would be able to deliver a lower torque, and third gear even further, and fourth gear are straight drive. So the whatever the gap that has been raised in the previous case is filled by means of introducing different gears into the existing system. And whatever the profile of an electric motor agrees well with the profile of your ideal power plant. So the electric motor is able to deliver a high torque at low speed, and it optimal power output at high speed. So all put together, this electric motor would be a better option for your internal combustion engine ideal power plant. But whatever the electric motor that we use for the existing industrial application won't get implied with your electric motor, because the electric motor that used for your existing industrial application would have the predefined operating points. So let us assume a lift coupled with an electric motor for the propulsion. So if the lift is able to carry only 1000 kgs, and if any one additional person is allowed to get into it exceeding this particular kg, you will have a beep sound, and the overall operating range of your battery is allowed to get restricted. And only until and unless you will have a weight of 1000 kgs, your lift would be operated. So one of the person would walk away from the lift to compensate this particular weight. So the optimum operating predefined points are already optimized, and accordingly the battery, the motor performance would get increased. But that is not the scenario for your electric motor used in your vehicle. So you will have frequent stop and go, high acceleration and deceleration, all put together. You need to face a different environment rather the electric motor used in your industrial application point of view. So the commonly used electric motors of PM, induction motor and switch electric motors, and induction motors are preferred by Tesla and Toyota Rev model, and even most of the vehicles are making use of PM and switch reluctance motor also. And this give you a brief explanation about the induction motor working. And talking about the batteries, in the earlier stage, as described earlier, why the batteries or electric vehicle plays a huge role in the automotive market share is because of its weight. So in late 19th century or in the early 19th century, the weight of the battery was enormously high. It would be merely the weight of an elephant that you need to carry along with your vehicle to move forward. But as the year keep on progress, the weight of the vehicle have battery have actually start to get reduced. But in an alternate way, talking about the energy share, so the gasoline energy share from the 19th century to 20th century or 21st century, the energy share of the gasoline is closer to 1200, sorry, 12,000 watt hour per kg. But in the early stage, the energy was only 10 watt hour per kg, and it has been keep on increasing at this particular point of time. So it won't be able to get closer to your internal combustion engine energy share, but we can just rely on near future to have a better energy. And as of now, most often cases, we are just relying on lithium-ion batteries for our electric vehicle and our mobile phone and laptop energy usage. So in late 2015, the overall demand for lithium was not too high, but as the year keep on increasing, the demand for lithium has also started to get enhanced. And particularly as described earlier, by 2030, the overall demand for lithium would face a drastic demand, and that should be dominantly used only for the passenger EV, because relying with the news as described earlier, by 2030 the vehicle population, particularly electric two-wheeler vehicles, would be higher, and the most of the lithium batteries would be effectively used for your charger vehicles. And talking about the reserves all over the world for lithium, so Chile is having the maximum reserve, followed by Argentina and Australia. And by 2030 or even further, the dependency of the lithium would also get a peak, as we have discussed for the gas price. So sooner or later, you might have a presentation like this stating that we may get switch over from lithium to a different energy source because of its huge demand by the year of 2030 or even later. So extensive research is also running on to find an alternate energy source rather relying on one single uh, energy as lithium. And talking about the lithium reserve in India, so India is also having a minimal lithium reserve. They have noted down, particularly in state of Karnataka. But whatever the demand that we are going to have in near future would not be handled by this energy reserve. So based on the statistical data, it says that for the financial year 2017, the the import of lithium has been for a price of around 384 million, and for the financial year 19, it has been reported as 1.2 billion, and even it would get its peak as the year keep on increasing. So this lithium is going to be the ruling energy source for next 3 to 5 years at this particular point of time. And this gives you a brief idea about the working of lithium-ion battery. And Nissan Leaf make use of a battery pack in an prismatic type, whereas Tesla make use of battery as a cylindrical type, and even now they have converted their battery pack into a cylindrical type to handle the heat generation issue. So based on charging and discharging, the battery is allowed to liberate excess amount of heat. So think about your mobile phone. If you just charge your mobile phone and touch the back case of your battery, you can just feel the sensation of heat. So that is why the manufacturers are suggesting to remove the panel cover and charge your battery. If you just place the panel cover and charge your battery, the heat would be get insulated, and this heat would completely degrade your battery life and its performance. And even at the time of discharging also, you will face enormous amount of heat, as the electric motor and battery would be running at different operating condition. The heat liberation would be enormously high, particularly with the batteries. So that is the reason why Tesla has come up with a cylindrical battery, and it would have a better cooling option. So when you are having an prismatic type battery, so the area exposed for cooling is highly restricted. So they have overall reduced the battery size and converted into cylindrical and have a better option for cooling. So under the footrest, they have merely counted of about 7,400 batteries used for Tesla S model. So the main reason for reducing the battery size is for effective cooling. And these are the news related with this battery fire issue. So even the leading manufacturers such as BMW and Ford have taken a backrest, particularly because of this battery fire, that is improper cooling. And Hyundai has called upon most of its electric vehicle Kona because of one particular issue is this battery fire. So if the battery is not effectively treated for its cooling purpose, it might result in a very big catastrophic failure. And it might overall affect the battery performance. So this is what talks about the battery thermal management system. So as described earlier, in the early stage, the price of the lithium-ion battery was enormously high. And as the year keep on increasing, they have been focusing on a reduced battery pack size. And in vice versa, the demand is also be going to get increase in near future. So the dependency of only lithium-ion energy source should be get shifted to another alternate energy source to handle the future demand. And in terms of global energy share, merely two-wheelers would have an energy share of around 260, three-wheeler of 40 million, electric cars as 5.1 million, electric buses would get increased into 4 lakh, and electric metros at 180 cities, and electric trams or train line in 411 cities. So based on a clear prediction, it is well aligning with whatever we have seen earlier. So China would have a better EV adoption by the year of 2018, and they might even further increase, and US would follow the next. And in this particular case, sooner or later, India would also get combined to have a better electric energy conversion by 2030. And with this, let me just conclude the process. Now you can, if you have any further queries, you can just ask us. I hope I didn't bore you much for past 1 hour.
No, sir, it was a very wonderful session. Thank you so much. Now I request participants to ask their queries, any questions.
Sir, one question, sir.
Yes, sir.
Sir, can you show more on the regenerative braking? How actually the power is generated while applying the brake in electric vehicles, particularly electric vehicles? How it can be utilized? That can you throw some light on that, sir? Regenerative braking.
So in case of regenerative braking, what actually happens is the wheel will be rotating in a forward direction, and we will be introducing the brake to it. So that is the friction plate would be added to it, and we'll be restricting the rotating motion. So at this, between this rotating point and the friction contact point, the heat would be generated. So what we'll be trying to do at the time of regenerative braking is we'll be completely cut offing the power source to the end wheels, and we'll be trying to rotate the wheel in the reverse direction.
Okay, sir.
So at that time, what actually happens is your motor will be acting as a generator, and all put together, it will just put a pressure on your end wheels to reduce the speed, and that would create an electricity to charge your battery.
How they were trying to make it as to rotate in the reverse direction, sir, at that point?
So you will be asking your motor to get converted into a generator, and that pressure would be acted on your end wheels.
Sir.
Yes, sir.
Sir, thanks for your excellent presentation, sir. You covered all the thing about the EV in depth. My question is, what is your opinion about the fast charging, and what it will happen if on the effect on the battery life, sir? Because this is the most important part of the EV, that the charging, battery and charging.
Sir, we should just see this in a different perspective. So you will have, let's assume you're having a mobile phone. So whatever the mobile phone that has been launched as of now are coming with fast charger. Yeah. So at the time of converting your charger into fast charger, the percentage of CC and CV would get varied. So you'll be asked your mobile phone to charge in DC mode rather relying on AC mode. So when converting your charging option into a DC mode, the flow of electrons would be much more higher and the heat dissipation would be enormously high. So when you are just converting your charging option into fast charging option, what actually happens is the heat dissipation would be higher.
Yes.
And fast charging option is highly required to make a reliable the electric vehicle much more reliable at this particular point of time. So that is the reason why even all the mobile phones are getting converted into and fast charger option. When you just place your mobile phone charging for 30 minutes, you will get a mobile phone charge from 0 to 80%. So what actually happens is you will be asking the electrons to move from one particular side to other particular side at a very faster rate, and the heat liberation would be higher. When you try to compare both the cases, the heat generation would be higher, and you should focus more on the heat liberation. If not, whatever the accident we have addressed earlier, so electric vehicle, Kona has faced an accident. So I hope. So battery fire puts Ford and BMW to take a back rest, and Hyundai has called upon all its electric vehicles to focus on this only battery fire issue. So battery fire issue might happen. So that should be much more concentrated when you focus on the fast charging. I hope I have answered for your question, sir.
I got the point, sir. What is
Okay,
the whatever the life of the battery that we are claiming 3,000 cycle, 4,000 cycle like this? So
sir,
if you go for the fast charging, so what will the effect on the life of the battery, sir?
Yeah, it would typically affect the life of the battery, sir. It will just pull out to nearly 50% down.
Yeah.
It will pull out nearly 50% down for whatever your battery you have in your home. So think about the mobile phones that your fathers and grandfathers have. They will just only use for talking purpose. So the discharge rate is very minimal, and they won't have any add-on application to it. But when you just have a varied discharge in your battery, and think about the mobile phones that yourself and your sons have. So they used to have a number of applications, and they used to use it at a very rapid rate. So the discharge rate is high. So the overall cycle is allowed to get affected, and the number of charging cycles is allowed to get increased. All put together will pull the overall efficiency of your battery to a greater extent. But whatever the mobile phone that even our fathers and grandfathers use is having a better cycle as of compared to ourselves, because their charging cycle is very minimal, and the discharge rate is much more minimal compared to our stage. So it depends upon the end user's discharge rate or the user capability. I hope.
What is the actual difference between your prismatic arrangement and your cylindrical arrangement?
In case
Arrangement of cells or what else, sir? Because you
prismatic
clearly explained about the major difference why we are going for the cylindrical cell type to dissipate the heat properly or have proper cooling facility. So what is the exact difference between, sir? This prismatic
prismatic would be in a rectangle. Prismatic would be in a rectangle shape, sir. So it would be in a rectangle shape. Assume it is having an area of like this, and when you are just having to pass a cooling around to it, the surface area or the contact area between the coolant and the battery is a line contact. It would be very minimal. And rather having one prismatic cell, if you try to modify this into 10 cylindrical cells, and when you are just able to allow to pass a coolant around to it, what actually happens is it will have a better cooling compared to the prismatic to the cylindrical cell. So let us assume this battery is liberating 60 degrees Celsius, and if you are just making use of an cooling in this particular case, after the coolant, the temperature would reduce to 30. But when you are just making use of a cylindrical cell, the temperature might even fall to 20 degrees Celsius. So when you are just having a cylindrical cell, if you just think about, they are having nearly 7,100 cells. Tesla S model is having 7,100 cells. So the main reason for having this amount of cells is for the better cooling purpose and better interaction between the coolant and the battery cell case. Because this battery fire issue is a major threat at this particular point of time. So that is the reason why all are getting converted from prismatic type. So the prismatic type is nothing but the cell phones in your battery case. Back case, if you just see the back case, you will have a rectangle block type. So in that the cooling would not be much more efficient. So that is the reason, as described earlier, at the time of charging, they are asking you to remove the panel cover and charge the battery. So one of the reasons why the battery might get busted is because of this heat insulation.
Okay. Thank you very much, sir. Thank you.
Thank you.
There is one more question. Can you state some technologies that have the potential to replace lithium-ion batteries?
இல்ல சார் இது எல்லாமே கேன்சல் ஆயிடுச்சு
Sir, they are just focusing
Since they are in placement mode today.
I request other participants to mute
ultra
themselves.
capacitors
Tomorrow,
and
day after tomorrow, they are
sodium
going to have
metal air batteries.
So we have suspended all the classes.
I request all participants, if they are not asking question, please mute themselves.
There is one question.
Please go
Yes,
ahead.
sir. Yes, sir.
Hello.
Yes, sir.
Actually, when we go for the hybrid kind of this mechanism, when IC engine and electrical vehicle both are connected, so whether the means differential is the part, means in case of IC engine, we consider that near about 30 to 30 horsepower power that we are going to supply. In case of electrical vehicle, near about what can be the horsepower? First of all, what can be the horsepower of this particular? Because getting the shaft power of the IC engine from this to, and whether the differential will be same, whatever the mechanism in case of one you shared there. So how this?
Yeah, talking about mild hybrid, we.
Yes,
But
sir,
the
yes,
micro
sir.
hybrid, we won't change the existing system at all. We won't change the existing system. Just like your power start in your internal combustion engine, you might have purchased an Excel or TVS Excel vehicle, which was coming in earlier with a kickstart option. And now this TVS Excel vehicle is coming with a power start option. You might have purchased an Bajaj Pulsar vehicle initially coming with a kickstart option, and now coming with a power start option. So they won't change the overall system. So before the engine, they will try to add this particular composition. And whatever the power that is delivered by your internal combustion engine will be same. But only when you are just switching from your internal combustion engine to your electric vehicle, from micro hybrid to mild or full hybrid, the power should be effectively optimized. So Maruti Ciaz is making use of mild hybrid operation. So Fasino vehicle is making use of mild hybrid composition. So the main power from the internal combustion engine will be as same as it is, and you will get additional power from your electric motor and battery combination. So this will be only add-on power to the existing case to handle an higher demand. And it would talk about the engine management system and effective topology to handle the different operation modes. So I have given you 9 modes at which your hybrid vehicle would operate. So for that, you need to understand the existing topology for which particular condition, which mode should be activated, and what is the power demand at the end wheels, and which should deliver the maximum power. If the overall power is 60 watt is from 60 kilowatt is from engine, 20 can be supplied from your electric motor, or this would get vary. So that topology is my answer for your.
Thank you, sir. I have one question from my side. In Indian scenario, which hybrid vehicle, which type of hybrid vehicle has a future? Like apart from pure, let's say 100% electric vehicle, plug-in or mild hybrid or micro hybrid, which one do you think is, better one?
So as of now, Maruti Suzuki is the leading market share in four-wheeler vehicles. So merely it is in 2021 or before 2025, Maruti Suzuki Shift variant or Shift Desire variant would come up with its hybrid vehicle variant. So you can just make the internal combustion engine alive only by the term of hybrid vehicle, and in that they will have a different classification. Dominantly, they will focus on mild hybrid, which doesn't a major change in this existing system. But if you swing the inside topology to a greater extent, so people would try to stick on with mild hybrid rather moving to full hybrid. And if mild hybrid doesn't work, they will work on full hybrid to handle the current scenario and make the internal combustion engine. But most of the automotive manufacturers have started to come up with their own EV. But whatever the price they have invested for internal combustion engine would be handled only by coining their internal combustion engine as hybrid. To answer for your question.
Thank you so much, sir. If any of the participants have any questions, please they can ask. And one announcement, there is a link pasted in the chat box for feedback. All participants are needed to fill that feedback form. That will be considered as your attendance. So I request every participant to fill the feedback form. If any other participant has any question. Yeah. Thank you, Dinesh sir. Thank you for your wonderful session on inside of electric vehicle and hybrid vehicles. It was very interesting to know evolution of this EVs and IC engines from throughout the history. The session covered right from vehicles, very basic terminologies to recent trends in market, types of hybrid vehicles, battery technology, recent trends. So everything was very great. Thank you so much. I thank all the participants for patiently listening to this session. So I would request everyone to turn on their camera. We'll have a small photo session, online one. So I request host or technical team to take a screenshot also. So I request every participant to turn on their camera. Thank you so much, everyone. Now we'll conclude this session and we'll start with the next session at scheduled time, 2:30. So I request everyone to join back at 2:30. Thank you.